Number 27 in section 2.6, we're asked to find the vertical asymptote and the horizontal asymptote. Before we do anything with that, we probably should factor just in case. So we have x squared minus 25, we can factor that up to be x plus 5 times x minus 5. And our denominator, x squared minus 4x minus 5, that can be factored out into x minus 5 times x plus 1. Now, this is reducible. They both have an x minus 5 in the numerator and denominator, so we could just write this as x plus 5 over x plus 1. Now, for vertical asymptotes, we're going to take our denominator, in this case x plus 1, set it equal to 0. Now, this conveniently, we had some things canceled out, but just set your whole denominator equal to 0. Still a good idea to factor whether or not you have to cancel it out. But x plus 1 equals 0, we're going to subtract 1 from both sides, and we end up with a vertical asymptote at x equals negative 1. Horizontal asymptote. This one we don't have to set anything equal to 0, we just got to remember some rules. The rules that we have are n relating to m. So n is your degree of your numerator. I'm just going to abbreviate it as numerator, there we go. And then m is your degree of your denominator. So the degree of the numerator, whether you're looking at the original or the reduced, you have a degree of 2 here and a degree of 2 down here. The rules that we have is if n is less than m, so the degree of the numerator less than the denominator, you have a horizontal asymptote at y equals 0. If n is equal to m, it's y is your leading coefficient divided by your leading coefficient. Leading coefficient in the numerator divided by leading coefficient in the denominator. If n is greater than m, there's no horizontal asymptote. And instead, you have a slant asymptote. We're going to worry about slant asymptotes in a little bit. But in this case, we're dealing with the middle term, or the middle one, where n is equal to m. So we're going to take the leading coefficient now. Thankfully, it doesn't matter which leading coefficient we do. It's going to be y equals leading coefficient in the numerator is 1 divided by 1. In other words, we get the horizontal asymptote as the line y equals 1.